Hello and welcome to Neuro Navigator. Today's topic is action potentials level 1. If you want a more in-depth look at action potentials, please visit the next video. At its most basic level, an action potential, or AP, is communication between two neurons through changes in electrical potential as a result of changes in chemical potential. Here we have a communicating neuron's axon next to a receiving neuron's dendrite. Now is a good time to tell you that there are two ions that we're concerned with for this video: potassium, K, or sodium, Na. Both are cations, which means they are positive ions and will make whatever cellular fluid they are part of that much more positively charged. The receiving neuron maintains a negative resting membrane potential, which is represented on this graph right here. This is because proteins inside the cell are negatively charged. Although there are things called leak channels, which are like little gaps in the neuronal membrane which allow potassium to go into the cell and leave the cell, it's not enough to make a big difference in the potential. However, when this neuron sends a communication, the receiving neuron is going to respond. For the sake of simplicity, we'll say that these neurons are excitatory and are sending glutamate, an excitatory neurotransmitter. When glutamate is received by the neuron, it's going to latch onto glutamatergic ionotropic receptors and let in sodium ions. This is because when glutamate attaches, sodium is now able to travel through the receptor and into the cell. If enough sodium gets into the receiving neuron, it's going to hit what's called threshold, right here at the axon hillock. Now this is also represented on the graph up here by this dotted line. Now a second channel is going to open, called a voltage-gated sodium channel. When these channels open, they're going to allow for a massive influx of sodium and trigger more channels to open all the way down the axon. This positivity, or depolarization, also opens voltage-gated potassium channels. And now that the cell is so positive, potassium will be pushed out, resulting in hyperpolarization as the potential dips beneath the resting membrane potential. The two important things to remember here are opposites attract and sodium in, potassium out. If you want a more in-depth analysis of the action potential, check out the next video.